Hello, and welcome to Tech Connects, Dice's podcast where we dig into topics on tech hiring, recruiting, and careers that matter to you. I'm your host, Nick Kolakowski, and I'm going to talk to great guests every month about the current state of the tech careers world, including the tech job market, the hottest tech skills, what companies are doing to attract and retain tech pros in a historically tight market, and much more. Our next guest is Tony Chan Carusone, who's a professor at the University of Toronto and CTO of AlphaWave Semi, a tech company pushing forward a number of cutting-edge initiatives, including the design of custom silicon for artificial intelligence, hyperscale data centers, and much more. Tony thinks the semiconductor industry faces a number of key challenges that will need to be solved over the next several years and decades, including a desperate need to grow the talent pipeline of tech professionals who specialize in all the various processes related to chip creation. According to one recent report by Deloitte, the semiconductor industry will be short 1 million employees by 2030. And when you think about the centrality of chips to everything we do every day, you realize that potential lack of talent is a really critical issue. Let's listen in as Tony breaks down both the current industry and the solutions for the future. My big question is, so last August we had the CHIPS Act, which is designed to obviously stimulate the semiconductor industry in the US, lots of investment. But from what you were saying, there's also a potential for the semiconductor industry to be short. I think it's 1 million employees by the end of the decade. I think the some analyst report said that, which is an incredible shortfall when you think about it. So, I mean, but it sort of raises the question. It's such a critical industry and a critical technology. So what's behind the shortage in the talent pipeline? You would think that there would be talent commensurate to the moment or to the demand.
Yeah, I've been thinking about this problem for a long time because before I was CTO at AlphaWave, I've been a professor at the University of Toronto teaching integrated circuit design and semiconductors for over 20 years. And I continue to have my appointment there, interact with students all the time. And so I've been thinking about this for a long time. And, at AlphaWave, we see so much the tremendous push for new semiconductor technology, connectivity technology specifically to move data around in data centers, and the way that bottlenecks AI, which is something that is on the tip of everyone's tongue these days. And the semiconductors have been in people's hands and pockets and on their laps for a long time now. And yet we've always faced this problem that somehow it's really hard to make people understand the way in which so much of the technology that they care about and love rides on semiconductor technology. It's somehow abstract and invisible to them in a way that software, for example, is not. I think software, young people get exposed to it very early. It's easy to play with, get stuff up and running. It's kind of ironic in a way because the truth is that a software is actually more abstract. It's more of an abstraction, whereas hardware is actually physically real. And yet people feel like they can touch and play with software, I think, more than they feel that with semiconductor technology. So I think that's one of the challenges. That's why I appreciate the opportunity to talk to you today, talk to your audience. It's just to demystify that and get the word out about what tremendous opportunities there are and what an opportunity for impact on our on our daily life. Everything, right? Everything you think you care about these days in terms of technology probably rides on semiconductors.
Yeah. Yeah, no, definitely. In terms of the students you're teaching, and to go back to what you just said about software, if you're learning software, it's a matter of, for example, you master Python, master JavaScript, master TypeScript, whatever that is. But with somebody who's potentially interested in getting into semiconductors and sort of gravitating towards that hardware side, what do they need to learn? I mean, it seems like what are kind of the top skills? Does it vary considerably between specialization? I mean, where do you even begin if you're a student interested in it?
Yeah, the I would say that there's so many different applications of semiconductors because it does touch so many different technology areas that it depends on the application area. What are you kind of want to combine an understanding of semiconductor technology and circuits along with maybe an application area, expertise in an application area for which you have some personal passion maybe. So if you're interested in biomedical applications of electronics, then you might couple that with knowledge in that area, but then again, couple that with an understanding of semiconductors and the associated circuits. For me, it's always been connectivity and high-speed communication. And it motivates me, right, to see these new technologies come online and just what the miracle it is that we can have a video chat like this or or on your phone, even while I'm riding the train. I mean, that just seems magical to me. So that's always captured my captured my passion. And so, and there you're coupling again, it all, the integrated circuit design, the microchip design is where the rubber hits the road for that technology. And then you've got stacked on top of that mathematics and signal processing. It's really applied math, really, that's riding on top of that. So I think that's a great thing about working in this area is that it's a kind of platform on which all these other things ride. If it's artificial intelligence, obviously, again, it rides on processor technology that's implemented in semiconductors. So I think that would be my advice to a young person. And when I speak to my own kids, they're getting the age where they're starting to pick future direction for themselves. I can't help but encourage them to follow their interests, but at the same time, there's these kind of table stakes understandings that you need to have, and along with software, which I think now people generally accept some comfort with software as table stakes for working in a lot of different fields. I think we should get to a place where some understanding of hardware and electronics is also table stakes for doing a lot of the work that you think you want to do in the future.
Yeah, no, that makes total sense. In terms of, so there's been, when you look at the data produced by the US Bureau of Labor Statistics or CompTIA or what have you, you see this incredible demand across the entire tech spectrum for all kinds of skills, whether it's people who can develop machine learning models or program in whatever language or what have you. And a lot of companies are reacting to that considerable demand by, and oftentimes loosening their previous requirements for the jobs. So, for example, whereas before they might have demanded a BA or certain certifications or whatever, they're often turning around and saying, okay, if you can demonstrate these skills in a technical interview or whatever, you're in kind of major contention to be potentially hired for this role. Does the same thing apply for people who are who want to get into semiconductors? I mean, is it one of those things where, I mean, are there people can sort of master a particular skill set and maybe not have a degree or a formal education but break into it, or is it a sub industry that really demands that people be properly credentialed and have all the right certs and degrees and everything like that? I mean, how kind of formally structured is it, especially vis-a-vis these other tech tech industries, tech interests?
Yeah, I think one interesting difference and trend that's emerging now is the fact that so much software work can be done with open source tools, openly available tools, and that has traditionally been not the case when it comes to microchip design. Interestingly, there is now a lot of movement on that front to make available open source tools for microchip design to enable younger people without not inside a big institution with a lot less money to be able to design a chip and actually get it fabricated and get it back. There's these programs to allow people to code a chip, right, and just essentially describe a whole chip with a similar kind of language you would a software program. So I think that's happening for a number of different reasons. One of them is to open up the doors of innovation, product innovation, to more people. And it's also to pitch a bigger tent to include people with different kind of interests and different kind of skills, right? And to allow them to participate in this exciting area. So I think that may that's one, back to your original question, that's something that's traditionally been a barrier to allowing people with different backgrounds into this field, but that is changing, I think, over time as these tools become more common.
Do you think that companies that are fabricating chips can sort of do more to appeal or change their argument to people? Or do you think a lot of the companies out there are doing just fine in terms of selling this as something that people would want, as an industry that people want to jump into? I mean, do you think there's for want of a better term, kind of a marketing issue too?
I think we can do better as an industry on, again, making it clear to all people how critical our technology is. Number one, how impactful it can be. For some people, motivations are different. For some people, it's the opportunity to have impact on the real world. So again, we could do a better job communicating to people how much of an impact our technology has. For some people, they're motivated by opportunity for wealth creation, and even there as well. There's lots of examples that people know about. Someone who started a software company right out of college, made a big hit out of it. Um, but there are corresponding stories in the hardware space too. Alphawave Semi is a good example of that. It was founded in 2017, and 4 years later, it was a $4 billion IPO, and it was founded by a bunch of folks I went to school with, and so it started with no venture capital investment in the garage, so to speak. So these things do happen, and there is a path there, and moreover, there's the opportunity for young people right out of school to hit the ground running, have an impact here, have an opportunity for financial gain. A lot of if you look at the semiconductor companies, it has its ups and downs, just like software, like we've seen in the big software giants in the past year. But there certainly are ups, and there's certainly many examples of companies that have produced tremendous wealth creation in the semiconductor space. So I think, and yet somehow that perception's not out there. I think the semiconductor industry is perceived as a little more staid, a little less dynamic compared to the software industry. So um, I think those are a couple messages that we need to get out. The other thing that I think doesn't help, and that and unfortunately even within the semiconductor industry, it's fractured. The messaging is fractured. Is you've got a prevalent picture of the semiconductor industry in the media, and it even comes from some industry players as well, that the investment is needed in factories, and that the talent that's needed are going to be people running around in white bunny suits, right? But in fact, there's a lot of high value adding activity, all of it that I see at a company like ours and other fabless semiconductor companies, which are in some cases massive semiconductor companies that have no fabrication at all facilities. The high value adding activity is done by people. What are they doing? They're using software tools, they're writing scripts, they're writing code to describe designs, they're verifying those designs. And then, yeah, some of them are in a lab, not in a bunny suit, but using advanced equipment to take measurements. They're writing software to take the measurements and so on. So it's a very dynamic environment as well. And so, yeah, I appreciate again the opportunity to just try to get that message out to more people.
Yeah. There was an article this morning, in fact, about how Microsoft had been secretly developing a chipset to allow it for kind of more efficient AI processing, obviously probably tied into all its work that it's doing with OpenAI, which I thought was really interesting in terms of like where the trends might be going. I mean, you see all this, it seems like there's a lot of obviously processor intensive stuff that's coming up, and a lot of companies are embracing AI and machine learning. So that's going to be interesting to see where that goes. I imagine, I mean, and correct me if I'm wrong, but software trends tend to be really rapid and sort of what was hot in terms of software development. Yes, last year is not necessarily sort of what's hot now. Do you think, especially with kind of the rapidity of AI and so on, that semiconductors, do you think like it's a sub industry that's going to sort of speed up in terms of design and trends and things like that, or is it? Um, do you think that the patterns are going to be slower? I mean, how is that going to go? Do you think?
Yeah, I think the big picture to keep in mind here is that the development of a chip is an expensive, complex task. It involves a lot of people's effort over several months. And so that effort is justified whenever the final design is going to be used over and over again, and you're going to fabricate that chip in sufficient volume to justify all the effort it took for the R&D. So initially, AI was being deployed on general purpose processors, then on GPUs, then on increasingly specialized GPUs. But now, with an explosion in AI and chat, this relationship between OpenAI and Microsoft's a good example. An explosion in AI. I mean, there's going to be so much silicon needed to support all that processing that guess what? It justifies making bespoke silicon for that application, and tailoring a chip to this type of language processing and maybe this type of self-driving car application, and so on and so on. Because again, with the explosion, it's just more silicon needed, more wafers. You're always going to reap the benefits either in terms of power, performance, or lower cost by having a bespoke design as compared to a general purpose processing unit, right? So you are going to, and we're seeing that absolutely at Alphawave Semi. We're seeing more design starts happening in more companies to try to build these custom purpose-built chips because again, the volumes are anticipated to keep going up.
I could be wrong, but in terms of the CHIPS Act and all the facilities that they're bringing online in places like Arizona and so on, those are all gonna those are all kind of custom fabrication facilities, right? Or are they more kind of producing more generalized processors? I mean, is all this investment going more in that direction of kind of custom?
Well, when you build a fab line, you make a massive investment in building that manufacturing facility. It is very important to just keep it filled, keep it occupied, and keep all that equipment highly utilized. Um, so once it's there, my expectation is that it's going to be used for whatever fills the fab line, right? Whatever keeps those machines running 24/7 is going to be what they're going to be building. So now a lot of it turns out that one of the main consumers of silicon is data centers, right? So there's so much silicon needs to go into those massive compute installations. And again, because of the rise of AI, that's only forecasted to increase. So they're going to be used. A good portion of their capacity is going to be used to deliver silicon into data centers. And then now, whether it's going to be running only three different chip designs through the fab line, or is it going to be using 10, 20, 50 different chip designs, each for a different application? That'll be interesting to see how that plays out over time. That's really a sort of marketplace competition issue. I mean, who can come up with the best solution, right, for those data centers? I tend to think, again, I already shared my opinion about that there's always fundamental benefits to be extracted from tailoring a design for a specific application, as long as there's enough sort of revenue on the other end of it to justify that R&D. Then you're going to just see more and more design starts going into those facilities. I think that's the direction it's going.
From a project management standpoint, in terms of the fabrication facilities, that also sounds like a little bit of a nightmare. Like if you have all these lines going and everything is highly customized. I mean, it's an interesting challenge potentially to solve, but I can also see like some, the whatever the foundry equivalent of a project manager is or a product owner, like tearing their hair out trying to like manage all these timelines and everything else and all these custom lines. It's crazy.
Yeah. I mean, the fabrication line, just to be clear, like the processing flow, the way they process the wafers into chips, that they will keep very, very consistent for the reason you said. I mean, reproducibility in the manufacturing process is absolutely key for these technologies. They're manufacturing things that are a countable number of atoms and dimensions, right? So they're going to keep all that super consistent, but the tooling essentially they use, the mask layers that they use to pattern the chips onto the silicon wafers, those can be swapped in and out for different designs. Now there's still, but your point is good that yeah, you probably if you were running one of those facilities, you probably wouldn't want to have to change the masks to run one wafer at a time through. No, they're not going to want to do that. They're going to want when they tool up for one build, they're going to want to run a bunch of wafers through and then switch over. So yeah, there's a kind of a sweet spot there, and they love high volume They will love high volume products absolutely, and that's why they love data centers, right? Those generally tend to produce lots of lots of processor chips, lots of connectivity chips, and just repeat and repeat.
Yeah. Do you think, I mean, if all this volume is picking up and we're moving into this new kind of incredible customized era, do you think that STEM, in order to meet the talent pipeline and overcome this gap, do you think schools are going to have to change how they approach STEM? I mean, particularly kind of more technically oriented schools and what they're teaching if they want to kind of generate the enormous number of people who are going to be able to slot into these roles? I mean, is there an education gap and what's in that gap?
I think the fundamental when you're talking at a young age, the fundamentals are, just the maths and the sciences. And I still think that, we can do a great job teaching that to young people. Again, I've got my own children, and I see that the main gap I see is just exposure to the technology, uh, so that they're comfortable with it. There's a confidence there, and just to demystify it, right, to make sure that you're capturing the interest of as many young people as possible. And I think that's starting to happen. You've I think there was a wave maybe 10 years ago where young people were first being heavily exposed to coding in classrooms at a young age. And then you see a more recent wave where you've got little hardware boards that they're starting to play with, and even at a super young age, getting lights to light up, and then as they get older, doing more sophisticated things. And I think that's great because it shows, you're using that hardware ultimately, and you're configuring it ultimately just by writing more code. And again, that's the reality of the situation. Even complete chips designs are described largely by codes and scripts. So it's not that, it's just a demystifying of it, and letting people play with it and see that they can actually do this, right? So it's starting to happen. We just got to get that democratized across the whole education system, I think.
It also seems, I mean, between Alpha Wave and all these smaller kind of, well, I mean, 4 billion billions of dollars is still pretty big, but smaller compared to, sort of the chip fabricators of decades ago and so on. I mean, it seems like, I imagine there's probably a lot of companies that are going to start spinning up if, there's sort of this custom demand, and then also if the tools to be able to kind of fabricate and create, are widely available. I mean, it's no longer going to be like Intel where you need $100 billion in investment in a $20 billion facility before you can get anything off the ground. I mean, I imagine the opportunities are going to be there too for people who have a kind of creative ideas about what to do.
hmm I think one of the big pushes to democratize innovation for chips is to enable what's called a chiplet ecosystem. So chiplets refer to relatively small chips that can be combined inside of a miniature package to create a new system, depending on how they're mixed and matched. So this is something that does take place now only inside of a few large semiconductor companies. AMD's been public, and others as well, Apple and so on. So, but there's a tremendous drive to democratize this technology so that more companies can play in this space. Because exactly as you said, um, by ensuring that different companies can innovate and that their little chiplets can come together and be connected, mixed and matched, and build a system that'll work right out of the box, that allows third parties to then come in and grab chiplets and put together new systems to address a new need within a matter of months instead of spending years to design a custom chip for that. It also allows smaller companies to just focus on the design of just a chiplet, right? Which they may have particular expertise on one part of the system. Now they can produce a chiplet that just takes care of that purpose, and participate, and yet have huge volume for that. So there's a lot of push behind that. A lot of effort in the CHIPS Act is going to go. A lot of the money in the CHIPS Act is going to go to enabling this ecosystem. So I think it's inevitable that this becomes a new model for designing really big, complex electronic systems, is to base it on these multiple chiplets.
Are you optimistic that the talent pipeline will be filled? I mean, do you think that we can reach it by 2030 or whatever, that we can reach a state where there's kind of adequate talent out there to address all of this?
Sure, I'm an optimist. I just think that we can't. It's going to take a lot of multiple things to happen at the same time, and we've got to. And what I fear on the other side is that this will be in the news for a year to 5 years because of the disruption of the semiconductor supply chain that we witnessed over the last couple of years, and that then it'll fall off people's roadmaps, and we'll lose attention. And then requires a long sustained effort. A talent pipeline is a long time constant associated with it, of a decade or multiple decades. So we've we've really got to keep at it. Recognize that semiconductors are going to be a strategic technology for a very long time to come.
What do you think it'll take to kind of keep the attention? Because, like you said, I mean, there are these shifts, there are trends, there are adjustments. I mean, is it just a matter of just? I mean, what do you do? I mean, I don't know. I mean, how do you keep that attention focused?
Yeah, I think you've got to attack it at multiple levels. I spent, I guess, a fair bit of time talking about getting hardware, getting young people comfortable with hardware, getting it into their hands, making it feel tangible to them. That's just one thing. You've also got to ensure that at there's specific inflection points, I think, where young people are setting a course for their education and for their career, and you've got to make sure that they're aware of the opportunities and the benefits and drawbacks of every direction. And then you also need to make sure that the higher education level, that the pipe is wide enough, right? So you have to ensure that there are faculty members at lots of universities, not just the big schools in Silicon Valley, but across the country, across the continent. And I'm in Canada, that are training students. You know, there's faculty members with this expertise, training students with this expertise. That all those universities have all the tools they need to do so, the software tools that are needed, the access to fabrication that's required, because prototyping and building stuff and getting it back and powering it up in the lab is an indispensable component of training, I think, in this area. So and so some investments needed there too, absolutely. And I think if we do all those things and we stay at it, we don't just dump a bunch of money into it and then forget all about it, right? But we stay at it consistently, have a plan, a long-term plan that can be sustained, I should say, and keep at it for a decade. Then absolutely, the thing that we have going for us in North America is that it's a great place to live and work and raise a family, and an open society that I love. So I think we have that going for us. We've just got to get these pieces in place.
And that's it, folks. Chips are so pervasive in our everyday lives, powering everything from our smartphones to our cars and appliances, that sometimes it's easy to forget that they're even there. So it's illuminating to talk to someone like Tony, because he illustrates just how central chips are to everyday life, and how quickly the semiconductor industry is evolving in new, interesting ways. Here are a couple of key takeaways from our discussion. First, if you're interested in a tech career, think seriously about semiconductors, especially if you're interested in hardware and electronics. You'll have a real chance at making a huge difference in people's lives if you help advance the semiconductor industry forward. Second, the semiconductor industry is really speeding up. As Tony mentioned, there are open source tools to enable microchip design. There are startups trying to create custom silicon for next generation functions such as artificial intelligence. There's a lot of opportunity out there for anyone to have an impact and contribute critical ideas, even if they're just out of school. If you want to break into the field, gaining a solid foundation in math and science is critical. From there are lots of pathways to specialize in different aspects of the field. Third, the semiconductor industry will remain absolutely critical for a long time to come. But even with all the attention devoted to building up a talent pipeline, there's every chance that demand for tech pros in this particular industry will sustain well into the future. So keep an eye on how this field is evolving. It could make a good long-term play for your tech career. We covered a lot of other topics, of course, so give the podcast a re-listen if there was something you missed. And we'll see you next time. Remember, DICE is your best resource to find the tech talent you need to fill your open roles, and for tech pros, the best place to grow your tech career.